Good evening, everybody. Do you hear me? Okay. Perfect. It's the last session of the day. Thanks to be here. I'm Roberto Freato. I'm from Italy. I'm here today to talk to you about I think that's not the topic of API gateways, and specifically one implemented open source that's called Ocelot in ASP.NET Core. Okay, how many of you have built APIs in the past? Okay, perfect. And implemented API gateways of any sort? Okay, a few. Okay, good. Some assumption when we build an API is, okay, we just have an API, so expose it, deploy it on Azure, on the AWS, on Google Cloud, on something else. So in my opinion is not really a good approach, because when you have an API, you probably will have another one. And for the same API, you will probably have another version. So in my opinion, it's best to deploy it from the start behind something that can be just a reverse proxy, for example. Another assumption, even false, is we are developing a new API, so we need to fit everything we want to fit now and even think about the future. So which is the best API I can build for my job, my company, my startup, my product? And in my opinion, is wrong, because we need to fit our mental model at the time being. So what is the product now? What is the project now, not in the future, because this adds complexity. And if we start from this assumption that the API can change a lot, we can have several versions of API. So it's really important to put something on top on this API from the beginning, because otherwise versioning can grow up and you can have a mess in your architecture, in your deployment configuration. Another pitfall is around the microservices, not just microservices. When we build a microservice, we should enter in another model. That's it. It's just a philosophy. So, in my opinion, the common mistake is to think of microservices when you don't need microservices. So, when the company is too small, when you are just developing a new product and you want to do microservices, but why? Because you want to create modules, because you want to scale. So this is a good open question about this session. I have no suggestion for this, but I think that each service should follow its own guidelines in terms of storage, in terms of languages, in terms of team. So you can probably, in your company, you can have a team that develop in Python and another team that develop in C#, and the C# one uses SQL Server and the Python one uses MongoDB. And it's okay. You don't think about microservices as something interconnected, so it's a very common pitfall. And when you think about microservices as different building blocks of your application, it's very important to put them under an API gateway. Last one, we need to accustom with the idea that we will have many versions of our API. Okay, these are the main assumptions. Well, API gateways have some general features that are routing or proxying, so the capability to, for a given route, go to a backend service or another backend service. They can they can act a single point of monitoring and logging and collect analytics. They can provide some error management features. A good feature is the documentation and API portal. For example, when you have a startup that has a product and a product is API related, you would probably create a portal where developers can sign up self-service to get the API key and interoperate with your service. These features are often offered by API Gateway, so it's an important feature that you can speed up your process of development. Traffic management, when you query a Google API for Google Maps or Translate, if you insist, if you hit continuously the service, Google will reply you, stop, please, or stop the traffic because of throttling. The throttling is one of the building blocks of each distributed service. You cannot give all the traffic your client requests to you because of other clients. So if you have shared resources, you should put some limits to your clients because of the others, okay? And so on. Caching, for example. Well, in this period of time, we have some commercial products. I don't know if you know any. Someone knows APG? Okay, no? Now, they are commercial products, very impressive and expensive also. In my opinion, one of the most critical reason people in companies doesn't adopt these commercial products is for the cost, the initial cost, the learning curve. So my suggestion is, because you need an API gateway, even if you don't know, you should start with an open source alternative. That in this case of the session is Ocelot, an open source project that is hosted on that GitHub URL. Okay. Well, let's show the scenario. I want to put an API gateway with its own storage for configuration purposes on top of two APIs, customer API that is running on this URL and sales API that's running on that URL. Let's see the deployment. We have an Azure deployment. This is a SQL server. It's like a logical version of a SQL database with two databases. One is data and one is data staging that has the same data with some masking. So just to replicate a scenario of production and staging database. This is a service called AppService. It's like, how many of you knows AppService of Azure? Okay, my advice for the others is to investigate that because it's a real advanced platform of a service product. For example, in this case, we have a pool of machines that are completely transparent for us, so we don't need to manage any virtual machine, any infrastructure as a service resource. And on top of this, we can run many containers or containerized ASP.NET application, even in full framework or in another language. So in this case, I deployed these two APIs that have these two URLs that are these two projects. One is full framework, is written in Nancy, just to show that each API can follow its own path of development with no assumptions. And the other one is a typical ASP.NET Core API with some roots like get the sales, the specific sale, all sales, a sales of a customer, and so on. I deployed these two API on Azure, and they are the prerequisites of this session. Okay. For example, this Postman collection is available on GitHub on the repo. I will show you at the end of the session. If I hit this API, that stands for give me the first 10 customers, I got this data. Give me all the sales. We have an array with the sales, a sales of a specific customer, is something like that. Okay, so let's start by building our API gateway from scratch, okay? So, I create a new ASP.NET Core application, empty in this case, we don't need anything, 2.2, with container support on Linux. And we add the dependency of NuGet that is called Ocelot. That's like an animal, this one. It's a pretty good library with a few dependencies, so it's nice to use and quite light. Okay, and now we need to configure that. Services add Ocelot. Okay, we need to pass the configuration of Ocelot that we are building now. Ocelot is based on a typical file that is called ocelot.json that I'm adding right now, that contains all the information we need to run the API gateway. Now it's empty, of course, but I configure it to goes in the build pipeline. Okay, I passed a sample that I'm explaining to you. In this sample, it's a basic configuration. We have an upstream template that says, okay, if we hit this URL with get meted, then go to this resource in HTTP, plain HTTP in this case, get this resource and give it back. Okay, it is just a simple reverse proxy mechanism. Just a few configuration steps. I say create a new configuration. I say let's create a configuration builder. Let's set the best path. Let's set the app settings typical file. And let's say, no, I don't want it optional, and reload if it changes. The same for Ocelot JSON file. Okay. This configuration can be taken by the Ocelot engine, and finally, we remove this default handler, and we say app use Ocelot. Okay. It's correct. I need just to make a hack because of my Postman collection is configured to this port. No, stop it. And let's start the project. I'm expecting to call this URL and to receive the content of the CBA, RSS feed, etc. But there is an issue with this initial configuration that I show you just for demo purposes. If you notice, the URL changed because the URL, the backend service, has a redirect. And by default, also do not follow redirect. So an option to do that is to specify in the Ocelot file to provide a mechanism on which for this specific route, in case of redirection, the API gateway will follow each redirection phases. Okay? In this case, we have a completely transparent situation with the same URL, of course. That is the thing we want. Okay, so this is the basic implementation. So we learned that Ocelot is a NuGet package, is delivered as a NuGet package. We just need a configuration file and some little lines of code to declare it. And we see how to deal with this little brief redirection issues. Okay. Now let's going through the proxying. So we have these two APIs, customers and sales, and we want to proxy them in the API gateway. Let's come back to the configuration. Let's change this. For example, let's start from the customers API. Let's say V1. I decide a path, customers, and URL. What means this? That everything is after the slash is usable here. So in this case, I take the API path of the customer API on plain HTTP, and I say API slash URL. Why I say this? Because if you go here, you say that everything is prefixed with the /API. I do this. This is not necessary anymore. And I create the other route for sales with the other URL that is here. Okay. Okay, let's save and go ahead. Now the query is on the API gateway itself. This is not a good URL because it's a repetition of customers, less customer, but we see later how to fix that. And we have the result as we expected. The same for sales. Now, if we want to customize this URL, because sales/sales, it's something that I don't like personally. We want something like that, sales/all, for example. It doesn't exist at the time being, but I can create it. I can create a route that maps specifically to the previous URL. Let's do that. Let's say sales all to API/sales. There is a potential issue in this configuration. Anyone notice that? It's a rule that can be applied on an order base. So, of course, this pattern hits this rule. So, to set specific routes, we need also to define a priority that is 100, for example. And now, in case of collision, we insert the route that has a priority, higher priority. In that case, says all. Okay. So, this is the same technique as we said in the previous demo, but with specific APIs. So we map the two APIs on two virtual URLs. I use the plain HTTP endpoints because if we have an API gateway or a reverse proxy or a firewall, it's good to make the SSL termination on that side. It's good. It depends on the context, but probably it's good to avoid the SSL handshake, the HTTPS handshake, even between API gateways and the backend service. Because your clients will go to the API gateway that will be HTTPS itself, okay? We saw that routes can be overlapping, we do with priorities, and we go ahead. View model composition. When you have, I work with a company, an ex-startup that has an e-commerce product that has a page that is filled by many building blocks. The cart, the basket, the feed of the product, search engine, the profile, the username, the identity part. Each part of this page is a specific microservice, but in some part of my application, I would like just a common view model, the view model of that page. And when we create a view model that consists of the composition of parts of many microservices, we're talking about the view model composition. So let's see a basic of this implementation with Ocelot. Let's say I want to create the customer sales. So a brief entity with a customer, a specific customer, starting from an ID, and its sales, an array of its sales, okay? So the route can be something like v1/sales of/ID of the customers, okay? First, I need to create two fictional routes, not so fictional, but just for this purpose. So I call them hidden routes, I call them service routes. So I want to make them hidden from the others because to avoid that clients can call it directly because it has no sense. So in this case, I create an overlapping customer root with a GID, so it's very hard to guess. In that case, I want the customer ID. And for sales, since in Sales API I already have the root give me the sales of a specific customer, but this root don't give me the details of the customers, I can use this root to say, hey, give me all the sales of these customers. Sorry, this is the wrong point. Whoa. Okay. Now we're just defining two different roots. Give them a name. This can be sales of part 1, and the second can be sales of part 2. The magic is in this configuration block that says, okay, let's create an aggregate with this virtual URL that aggregates these two single roots. Okay, let's try to debug this code. And we see this is the URL, v1 says of this ID is a real ID. But there's an issue in this code just because the implementation of Ocelot, when it acts as a proxy, it just calls the API service, and if the API service gives the reply with the gzip, for example, with the compression, API Ocelot treats it as it is. So this is a compressed response. So I will make a trick of Ocelot itself to avoid this issue that uses where is it? Okay. This option. With this option, I can say, okay, let's make some transformation of the header, the HTTP header I send to the backend service. And in that case, I want to say that the encoding gzip is with quality 0. So avoid this, okay? I do the same with the second. And now I'm expecting it to work. But the default behavior is to create these two parts with the key names. So sales part 1 and sales part 2. I want to create my own view model with just a customer ID, a name, and a total that is the sum of the subtotals of the array in the second part. So let's implement our own aggregator. We just need a class. That implements the interface of Ocelot I defined aggregator. This aggregator should be declared somewhere. Where? Here, we say for that template, use the sales of aggregator, and also in the Ocelot configuration, let's define to inject this instance. Okay. So let's implement the sales aggregator. In this case, when the aggregator is hit, we have just in the arguments the several backend service aggregate. In this case, there are two. So I can create a customer instance that is the response, first content string. This is the JSON of the customer. I just need the customer ID, first name and last name. So let's create a service class. It's not so optimal in terms of performance, but it's good for this demo. create a light implementation of the properties I need, and I do the same for the sales item. For the sales item, I just need this one, the subtotal, that is a double. Okay. Now I can take this and serialize to a customer item. This should be waitable. I do the same for the sales, of course, with another model. That's an array in this case, and not the first of the responses, but the second of the responses. And now I can return what? This is a model of Ocelot. It's just a wrapper of a response. Oops. That is a wrapper of an HTTP response message. That is a wrapper of the content. That is a string content in this case that comes from the JSON I'm creating right now, starting from this anonymous type that can be customer ID, for example, taken from the customer, can be customer name taken, this could be the composition of customer first name, space, customer last name, and the total, customer sales. That can be sales, sum, some link, now select, sum of the property subtotal. Okay, let's prettify this result. Some parentheses, and probably it's okay. Okay, excuse me for this code, but just to start from scratch, and some code is needed. Okay. This is probably because the settings are wrong, so which is my mistake? Oh, a comma? Okay. And now I'm expecting a different result. That's my view model that I want. Okay, clean, and with the only item I need for my hypothetical view. Okay? So, in this part, we learn the basics of aggregation, custom aggregator developed in C#, and some little fixes with headers transformation that can be even for other purposes. For example, if an API on the back end wants a header that is not attached by the client, you can inject it into the API gateway part. So it's a good practice for versioning, for example. The next thing is throttling, the traffic management. So the purpose is I want a client can hit just a few times for a given time frame because of my performance issues. So let's see how to implement that. There is a basic implementation in Ocelot, but it's good to start and good to make practice with these concepts. For example, the sales all route, that's quite impressive in terms of performance because it's like a select start from a table. I want to implement here a sort of throttling. So the two parts are, one, let's define there is throttling enable on this API. So in the global configuration say, okay, I have a throttling. In case of throttling, give me a custom HTTP error code and error message. Please stop. This is, we see later the purpose of this header. We have enabled the function, the feature. And the second part is for a specific route, which is sales all. here. Let's implement the throttling. In this case, I want to say, okay, if in a period of 10 seconds, you make more than 3 calls, then stop for 30 seconds. This is the logic. Let's see in practice. One, two, three. Please stop. Okay? Which was the purpose of the client ID settings? Because throttling is related to you in terms of you user authenticated or with a specific identity. So it's useless a feature that makes throttling by default, just on the anonymous user. You can relate throttling to a specific user. So the purpose is that if this test header contains my ID, the throttling is related to this ID. So after that, I also have the retry after, that's good for automation. I cannot call it anymore, but if I change my ID, of course, it's okay. No, oops. What's happened? Oh, it was test. It was test, yeah. Oh, query parents, I'm sorry. Headers, test. 1, 2, 3, stop. I change my ID, and I can proceed, of course. So, which is the suggestion? Is to relate the throttling feature to something that is very tied to the user. For example, its client ID, in a way that cannot be manipulated by someone else. So a good approach is to look into claims-based token, extract from the JWT the client ID and use this to enforce the throttling and make it relevant for your application. It's a very basic feature. In commercial products, you can throttle by several parameters, several environments, variables, and so on. But it's a good way to approach that feature and to make the mental model of the throttling in your company, in your product, in your API-based workload. Extension. I investigated into Ocelot to make some extensions, and I prefer to work by outside without forking the original project. So in my experience, I would need, for example, to create an extension to externalize the configuration, not in place with the file system of the unit of deployment, but somewhere else. In this case, on Azure Storage, Google Storage, somewhere else. So I can modify the Ocelot, that is the Ocelot JSON, that is published on the cloud, but the application has not been touched, okay? The approach is very simple. I have in this extension an agent that makes it work, so it goes to Azure and polls resource, check if there is a new version, and through the dependency injection of Ocelot itself with this kind of interfaces, it goes into the Ocelot engine and replaces the files in the application, in the unit of deployment. I also start another project that's called Transform for make transformation of bodies. For example, if you want to expose a new API that is not yet written, you can create a virtual path with a transform engine that creates on the fly a response that is an edit, a modification of a real response. So this is my second extension, but it's just in Sandbox right now. So this was the approach, and to see it in action, we can just install the NuGet package that is signed also. And we define in the app settings that we want to use extensions. The semantic here is configuration model, enable, okay. Which type of repository for the time being is supported, Azer and Google. The check-in interval, this is related to cost. This is polling, it's simple polling technique. So if I say 10 seconds, each 10 seconds it checks. So for with a calculator, you can notice that for Azer, this configuration updater will cost you about $2 per year, if I'm not wrong. I can, of course, say 1 minute or 30 seconds, and will cost you some cents per year. Of course, it depends by the cloud provider. I say I would like a blob provider with the shared key. These are internals of the blob storage of Azer. How many of you have used the Azer, Windows Azer, Microsoft Azer in the past? Okay, a few. The account name is Ocelot Extensions, and we have this tool to create a blob container and to upload the Ocelot file. So the relative path is .next/ocelot.json. The key is taken from here. Okay. How we see if it's working? Because it starts, no, it's not starting. I made some mistakes probably. Okay, Ocelot extensions. No. This is a demo, of course, something is going wrong. Let's see it again. Let's see if it works, just for, okay, working is work. Okay, for some reason it doesn't work, but I have a backup. So here, for example, the behavior is this: I check a new version. If I find a new version, I back up, I make a snapshot of the old one, and I continue to poll. And this is optimized because it checks by the head HTTP command without downloading the content if it's not necessary. Okay? Well, so I tried this path because I didn't want to fork the project and make pull requests. So the pattern is to use the interfaces of the Ocelot project and DI to inject different implementation instead of the original ones to make this kind of behavior, custom behaviors. In this case, with this configuration extension, you can make the deployment stateless because you should deploy your unit, your ASP.NET Core application, and the also.json configuration comes from outside on a refresh basis interval. Okay? The last two items, I talk about them together because they are pretty complex. The first is, okay, now we want to deploy it, and we use Azer and containers, and the service that is called App Service, that is like a orchestrator, a platform as a service of Microsoft that orchestrates the containers. It's not based on Kubernetes or something else. It's just a Microsoft technology. And after that, I want to show you how to implement the staging production environment. So the typical, if you sign up for an API, you will probably have two different URLs, API dot something and API minus sandbox dot something, okay? Because different APIs at the same versions points to different environments. So in the sandbox environment, for example, staging, you can hit fake data, or a fake environment, you can do everything you want. Okay, let's go with the containerization. We just have a Docker file, I just make some tweaks for Windows, Linux compatibility. Okay. I create an image. How many of you have worked with Docker? Okay. Many, alpha. Okay. What do I need to create a Docker image? I need a registry, and in this case we have a registry on the Azer platform. It's a very cheap service because it hosts the images of Docker. It's called API Demos, and we are building the image with the tag that is API demos.azercr.io/prd/.next with this file system. I have a passion about Azer from the first releases 10 years ago, and my advice is to use a platform as a service for your project to enlighten you from the governance effort of virtual machine, of infrastructure as a service. All these are platforms. So we have a database that is fully managed. I don't have any server to connect to in SSH or RDP. I have this services, there are platforms, so I have a machine, of course, but I don't have access to that machine. Everything is managed. I have the storage that is platform by definition. I have this registry, the same, and this DNS zone that is just a DNS zone, so very simple to explain. Okay, I have the image now, and I can push it to the remote repo. So I'm expecting to see it here briefly. Here. Now, I'm creating an app service instance that is also called web app, simpler. The resource group is just a logical group that groups resources in the Azer platform. It's a concept that is present also in the AWS. Here I can say the URL .next on a specific domain of Azer. If I want my custom domain, I can configure it later. I want to say that the content of this deployment should come from a Docker image on my Linux plan, and specifically take it from my Azer container registry with this image. Okay, next. And I create this web application. The underlying resource, the underlying Linux server farm is already created, so this is a seconds-based deployment. It's just to create a new container with this code. Under the hood is creating the DNS, registering, and so on. I'm expecting it's finishing in a few seconds more. Okay. Now under the hood is probably getting the container, getting the images, extracting, deploying. So probably it's not yet ready. This URL is not yet ready. I can go here, or even here, to see the logs of Docker. So probably here will come the logs with extracting, downloading, and so on. Okay, and now we have this API with V1 customers 10, that is, give me the first 10 customers that under the hood hits the other service. Oh, not fun. Wow. Oh, yes. It was tricky. Okay. So what we have now in place? We have a Linux-based container with .NET Core, with the API gateway, with the external configuration, with the 2 backend service, and in this real-world URL, we are hitting another API that is previously showed here on this URL. Okay, Last thing to do is the two environments. So I want to create two different environments, one from production, one for staging. So the first step is to have that environment, and I have this database that contains fake data on a partially masked data, and I have also this other web application that is very similar in terms of URL to the customer one, with exception of minus staging, that points to that database. So if I call this and say customers 10, I have real data with some masking, okay, instead of the production one. That is good. Okay, first thing is to create a DNS domain. I can go here. I can take my internal DNS and map it to a real DNS.next production. I create a CNAME type that is just like an alias. And I create another one that's called staging, pointing to to the exact same environment. Why I do this? Because I don't want two environments for the API gateway. I just want one. And I want to say in the configuration of the IP gateway, if you receive a call with this host header, go there. And if there is another host header, go there. Okay? How to do that? I can go here. And use this last configuration tip. For example, here, I say in case the upstream host is .next peerd.cloudmakers.xyz, so call this route. Otherwise, if it's staging, call this other route. Okay? Now, if the previous demo worked, this change is, of course, immediately propagated after 10 seconds to the containerized application. But since it didn't work, I can show you the result of my previous dry run. .next dry run again. That is production data, and .next dry run again staging. That is staging data. And under the hood, of course, just to make sure for you that I'm not scamming you, it's, of course, the same deployment. Okay? Well, in this last step, we see something that is not really related to the API gateway because it's Azure, it's the deployment stuff. But I give an accent to the platform as a service. So I give you a quick look around some services that I think they are useful in Azure. We use AppService, that's a fully managed platform as a service with a shared pool of machines where we can put on containerized application. We used the service registry, the image registry for Docker. We use a custom DNS, and the zone is configured on Azure itself. And finally, we use the host header configuration of Ocelot to perform this kind of routing. Well, I finished my presentation. I did not present myself before. I'm a consultant. I work with Azer and distributed application the last 10, 15 years. I wrote some book about Azer. And you can find all the stuff of this session, slides, demo, the code to build the previous APIs, the database code, etc., on this GitHub repository. Thank you, and if you have a question, I'm here for you.
Thank you. Thank you, Roberto. Okay, yeah. Here we are.
Thank you. I have a couple of questions, if you don't mind.
Yeah.
The first one, are there any opportunities to integrate with Swagger based on Ocelot.json configuration only?
Okay. For Swagger, for example, I do not integrate it into the API gateway itself, but I create in a solution with some microservices a specific application that contains all the Swaggers of the single APIs, just to avoid to do the documentation part in the Swagger generation the API gateway. Swagger in ASP.NET Core, as you probably know, is auto-generated by Swashbuckle. So it's not possible to put Swashbuckle inside the API gateway, since Swashbuckle goes into the controllers to see which are the routes and generate the documentation dynamically. So in my opinion, Swagger can be put off the API gateway.
Okay, thank you. And the second one? Could you please open the Ocelot.json file configuration?
Excuse me?
Could you open Ocelot.json file? Oh, yeah, that's it. Thank you. So we use the version, for instance, V1 as a URL path.
Sure.
What if we pass version as a content type header, for instance? Is it possible to configure Ocelot to use this way?
No, but in my opinion, it's a very valuable approach. So, for example, before Ocelot, we had a microservice infrastructure that has versioning based on headers, as probably any cloud service does. For example, Azer itself in the storage, you have the same URL and the version are distinguished by the host header you pass. So in that case, you cannot perform routing based on headers, but we can make an extension for it.
Okay, thank you.
Thank you to you and your listeners. Any other questions?
Hi, thank you for the speech. And my question is, does Ocelot works good with impersonation? For example, in enterprise intranets, your underlying API can work with Windows authentication, Kerberos or NTLM. So can it, with this rerouting, impersonate calls?
Well, it's a scenario I didn't experiment it directly, but in Azer, the backend service can be in a VNet, and you can perform a VNet connection to your on-premise scenario that is authenticated with your own authentication system. With the claim transformation of Ocelot, you can, starting from a claim, append something else where you want. With some extension, you can probably create some other stuff in the request pipeline. So I think you can probably do that, but it's quite complicated and tricky.
So there is no out-of-the-box solution?
No, of course.
Okay.
The purpose of this session is to say to you, in my opinion, you should start to use an API gateway now, if you have just one API. So if you don't want to use a commercial product because it's complicated, it's a learning curve for money, etc., you should take in place Ocelot that is free, open source, and as you can see, it's quick to use.
Thank you.
To you. Any other? Okay.
Thank you. I have a question about throttling. Can I use this feature as part of my ASP.NET Core application without rerouting and?
Without rerouting?
I would use throttling without rerouting. Can I use Ocelot as part of my application?
Oh, I didn't get the question completely. You say if you can use throttling feature without...
Can I...
Oh, without the API gateway? Oh, yes, you should implement your own throttling method. I tried actually to extract the throttling feature, but it's quite injected in the pipeline of Ocelot. So it's not easy to take that code and put somewhere else. But it's not rocket science. So as is implemented here, it's a basic throttling system. So you can probably see the code and take the good takeaways and replicate them in your code. But there's not a class you can take and put. You just have to make some adaptation. Okay. Thank you.
I see.
I don't see you. Okay.
Hello.
Hello.
Thank you for the speech.
To you?
Regarding the previous question,
Sure.
there is a Nugget package for it. I might tell you after presentation. It works as charm in our projects.
Oh, wow, great.
And a question, don't you think that it's overkill and the view composition, it looks like that the domain logic leaks into some other third-party service and you create tightly coupled components?
Yeah. Yeah, it's overkill, of course, and it's just for demo purposes. So here you can, for example, well, the question is complicated because in view model composition, you have to deal with two patterns. In one case, the client should be able to make the calls and compose them and take the parts of their interest. And this is quite complicated because the client can fail somewhere else. So yes, it's not optimized, but it's a good way to perform view model composition.
I can share our experience that we had to drop this idea because our front end became less responsive.
Okay.
And here you can lazy load something and implement.
Yeah, but I can say, I don't know your company, your situation, but I can say that your front-end guys and application should be aware of less possible. So you should give to them just a few calls and you should work on the performance side, for example, enabling caching on that specific calls or throttling to them. So you should relate to your people, to your front-end people as clients. So you should throttle them if they call you too much or with the huge APIs that calls, for example, a huge set of data. So I have not a strict opinion about this because it depends from the context, but I understand also your situation. But I think view model composition should be taking place when you have more than 3 services to call and compose. Thank you.
Thank you.
Last question, and then we should move to the discussion area.
Okay,
if
yeah.
there's a time, there's
okay, yeah. I guess it will be the last one. Yeah,
Okay.
yeah, okay.
Thank you. I will be quick. What about the localization? Is there any particular library that .NET Core offers about the localization, or?
The localization of your content under the APIs, localization in terms of translation.
Yeah, that's right.
Okay, well, it's out of the scope of the API gateway itself. It's, probably if you need some localization in your platform, you should deal with it in the backend services. Okay, if you don't have this in the backend service, you would probably want to create a fake feature that mimic the localization feature, but after that, you would implement it into the real backend service. So API gateways can help if you don't have a feature to quick implement something that is artificial, that is not true, just to give a quick step to your development. For example, a method that doesn't exist or something else. But then, in my opinion, it's better to promote this to a feature and implement this to the real backend service. So for localization, I don't have any suggestion for packages or something else, but in my opinion, the pattern to create new features is this one.
Thanks.
To you.